Fermat's last theorem, a very simple algebraic proof. Let c to the n equal a to the n plus b to the n, where c is greater than b is greater than a, and c to the n minus a to the n equals b to the n. Therefore c equals a plus delta, then a plus delta to the n minus a to the n equals b to the n. For n equals 2, a plus delta squared minus a squared equals b squared. Therefore, a squared plus 2a delta plus delta squared minus a squared equals b squared. The a squareds cancel, therefore b squared equals 2a delta plus delta squared. Therefore, a equals b squared minus delta squared divided by 2a delta. For n equals 3, we follow the same procedure and end up with the fact that b cubed equals delta cubed plus p delta squared plus q delta, a quadratic equation. The equation is indeterminate for a and b and cannot result in an integer cube root. For n equals 2, if we keep delta constant and calculate a for increase in b equals 1 to infinity, in the equation a equals b squared minus delta squared, all divided by 2a delta, then we get the integer input-outputs shown in the table for the following equations. 1. A equals b squared minus 1, all divided by 2. 2. A equals b squared minus 4, all divided by 4. 3. A equals b squared minus 9, all divided by 6. 4. A equals b squared minus 16, all divided by 8, and so on and so forth. You will notice that the equations are the difference of two squares. Firstly, all the results in columns 8, 5 to 8, emphasized in bold italics, are the a and b base numbers for non-primitive Pythagorean triples. The inputs-outputs for the first two columns in blue are the a and b base numbers for the first odd series of primitive Pythagorean triples, the Pythagorean series. The inputs-outputs of the third and fourth columns in red are the a and b base numbers for the first even series of primitive Pythagorean triples, the Platonic series. Every second pair of results are non-primitive, being double those of the odd Pythagorean series. It is easily deduced that all of the columns are and always will be non-primitive Pythagorean triples. This slide, taken from my Easiest Chips Pythagorean triples video, demonstrates how all primitive Pythagorean triple series can be generated from a plot of the first few triples of the odd series vertically and of the first of the even series horizontally. The series are ranked according to the magnitude of their constant series differences. The next two slides are from my classical proof video for FLT that I uploaded to YouTube in 2014 but removed earlier this year. Its argument is identical to the very simple algebraic proof, and I'll leave it there for you to peruse.